Here you see an oval printer produced by OMSO. Bottles are fed on an in-feed conveyor at the lower portion of the screen and transferred by a clamp transfer toward a print head. The clamp transfer is patented. At the print head, bottles are lifted by vacuum cups, rolled beneath the screen, and then returned to a rest position where the clamp transfer moves them toward the UV curing station. The squeegee and screen reciprocate above the oscillating fixture bar. This fixture bar was designed and patented by Autoroll in 1966. This overhead view shows a clear view of the reciprocating squeegee and screen, as well as the fixture bar below, which oscillates vertically. Here is a view from the rear of the Novax printer, which clearly demonstrates how the oval attachment is powered. A rocker arm to the right is connected to a lever on the fixture bar spindle by a tie rod. As the fixture bar spindle gear is rotated, it causes the fixture bar to oscillate vertically, the screen carriage to oscillate horizontally, and the squeegee carriage above to move in an opposite direction from the screen carriage. Here you see the assembly operating at a higher speed. This footage provides an excellent view of the reciprocating screen and squeegee, as well as the oscillating fixture bar below. To the rear of the fixture bar, you can see the tie rod connected to the gear on the fixture bar spindle. It is powered by the rocker arm to the left. This design is contrary to the language in OMSO's oval attachment patent, which indicates that the rocker arm is connected directly to the squeegee assembly. Autoroll's A10 was developed in 1989 and 1990, and here you see bottles being fed to the machine on an in-feed conveyor to the left, loaded onto a walking beam. Patents have been applied for this beam. The bottles are oriented prior to movement into the fixture bar, chuck and nose cone, printed, transferred back to the beam through the UV curing system, and then ejected from the machine on an off-feed conveyor. Another view of the same operation. Pick and place load. Bottles move along the vacuum-assisted beam. They are oriented prior to loading onto the fixture bar, printed, repositioned in a flat attitude, and then moved along beneath the UV curing light, and then off the machine. This view from above shows clearly how the screen and squeegee reciprocate and how the fixture bar oscillates vertically beneath the screen. In addition to the lift, you can see the bell crank drive which powers the printhead. In this case, the bell crank drive is attached directly to the squeegee assembly above. They both move in unison, and as they move, the motion is transferred to the screen, which oscillates in an opposite direction. This close-up view shows clearly how the hinged fixture bar oscillates vertically below the screen, and how the screen travels in one direction as the squeegee travels in the opposite direction during the printing process. There is also a clear view of how ovals are reoriented to a flat attitude as they return to the beam for transfer, for curing, and then off the machine. This view from the rear of the A10 shows a prototype oval attachment. This oval attachment was built for testing, taken to one trade show, disassembled, and never utilized. The oval attachment utilizes a rack and gear to generate the reciprocating action between the squeegee assembly above and the screen assembly below it. It is a user-friendly assembly, has dials and clamps which allows for simple setup and easy changeover. This prototype attachment used encoders mounted on the upper portion of the assembly so that setup positions could accurately be determined. While the idea was a good one, it was extremely expensive and abandoned on later attachments.